after you check your homework. So for our notes today, we are working on what we call piecewise defined functions. So what that means is you have different pieces from different graphs all on one graph. So if we look at over here, we have this piece of graph. That would be the equation x plus 3. And then we have this piece of a quadratic graph here, which would be our x squared. And then we have a third piece, which is another line, f of x equals 3. So they're going to ask you to take different pieces from different graphs and put them all on one graph. That's what our piecewise defined is. Now the way that it looks is it looks like this when they ask for it, which can be a little bit confusing, but each line goes together. So this is telling you this is the equation x plus 3 for all of the values that are less than -1. And this one's saying you're doing x squared from -1 to +2 only. And then you're doing f of x equals 3 for when x is greater than 2. So it gives you the domain for each of those different pieces. So let's take a look at our examples. So here we have two different pieces. We have the 3/2 x minus 4, and then we have the x minus 5 squared minus 3. So let's start with the first piece. The 3/2 x minus 4. We're going to make a table of values. I find table of values are the easiest way to graph these ones. So my 3/2 x minus 4, they tell me for my x's to go from -2 to +4. So in my table, I'm going to fill in my x's from -2 to +4. If we take a look a little further at our inequality, is there an or equal to with that -2? No, it just says less than. So that means at -2, I need to have an open circle. So I like to kind of bubble it in, so I remind myself when I go to graph that, that needs to be an open circle. All the rest of them will be closed circles. Because this one's not equal to -2, but it goes up to -2. So let's use our calculator to help us fill in the rest of our table. So we'll go to our y equals. I'm going to do my alpha y equals, the first choice to get my fraction. 3 over 2x. And what was the last part of it? Minus 4, thank you. So we'll look at our table. I'll go up to -2. All right, so we got -2, -7. And then a -11/2, 0, -4, -5/2, -1, 1/2, and 2. So once you have your points, we're going to go and plot them. So again, -2, -7. I'm going to put an open circle instead of a closed circle because it did not have the equal to. It was just a less than. And then I'm just going to graph my whole numbers. So then I'm going to go 0, -4. And then 2, -1. And 4, 2. And that's going to make our first piece. And then, of course, we label it. P of x equals 3/2 x minus 4. So then we have to make a table for the other part of our piecewise function there. So our x minus 5 squared minus a 3. So I'm going to set up for my table of values there. Our domain that they give us for that is x is greater than 4. So I'm going to start my x's at 4. I'm just going to fill in some numbers, 4, 5, 6, 7, 8, going higher than 4. Will I have an open or a closed circle at 4? Open, because it doesn't have the or equal to. So I'm just going to circle that so I can remember that's going to be an open circle. So let's have you go ahead in your calculator, type in under your y equals your x minus 5 squared minus your 3. And let's have you fill in your table of values there. So again, once you have your points, that first point, 4, negative 2, is going to be an open circle. Then 5, negative 3, 6, negative 2, 7, 1, and 8, 6. Alright, so let's take a look at our questions. They want us to find the value of P of 4. So again, what letter do we normally have in those parentheses? X. So we're looking for when X is 4. So if we go and we look at our graph, how many points do we have at X is 4? 2, but do we really have 2? That's why we got this open circle. Does that point count? No. So what is the value where x is 4? It's going to be positive 2. You got to remember, those open circles means those points don't count. So now find the value of p, or 2 times p of 0. So let's go to where x is 0. What is the value of our graph? Here's x is 0. Yep, that's negative 4. And then go to where x is 7. Where's our graph? Positive 1. So we got 2 times negative 4 plus a 1. So 2 times negative 4 gives us a negative 8. So negative 8 plus 1 would give us a negative 7. So in question number 2 on here, this is an example of kind of a multiple choice question they could ask us about our piecewise functions. So they give us this graph. We have to figure out which of these equations matches it, which when you see all 4 of them together at the same time, it does look a little bit overwhelming. But let's look at the little pieces first. Our open circle is on which equation, the line or the quadratic? The quadratic. So if I look at my equation, my quadratic should not have an or equal to, which that one doesn't, so that one's good. Choice 3, my quadratic has the or equal to, so that means it should be a closed circle on that one. So we know it's not that choice, so we can cross out choice 3. How about our last 2 choices? Are those ones okay? Yeah, those ones are okay. So we were able to knock out 1 choice so far. Let's take a look at our line. What would be the slope of our line? Pick 2 points. Our slope is up 1 over 2. So our slope is a what? Isn't it a 1/2? So that knocks out choice 1. Here I got a slope of 1/2. There I got a slope of 1/2. So now, what I'm going to look at is the quadratic, because if I look at my lines, those are the same exact equations of a line. We could look at the inequalities that go with the lines. My line is which direction of the -1? Right or left? Left. I heard somebody just say it. If it's to the left, should it be less than or greater than? Less than. I always said left. Less than. Always makes a little L. So is this one less than? Or is choice 4 less than? Choice 4. So it ends up being that one. You can't really use your calculator too much because your calculator is going to show you the whole quadratic, not just the part of it that you want. It's going to show you the whole line, not just the part of the line. So it really is not going to help you out with those ones. You just got to look at the pieces. So let's take a look at our last problem on the back there. Again, how many pieces are we graphing? 2 of them. The first piece is the absolute value of x. This question was actually kind of a nice question. It was a Regents question. It was one of the easier ones, thankfully, that year. So for our absolute value of x, what numbers are we using in our x's? -3, -2, -1, 0, 1. Are they all going to be open circles or closed circles or combo? Combo. Which one's going to be open? The +1. So I'm going to circle it. 'Cause again, there's no or equal to on my +1 there. So you could type this in your calculator if you wanted to get your table. Or we can just remember what's the absolute value of 3, absolute value of 2, -1, 0, and then absolute value of 1 is 1. Then we can plot our points. So it makes kind of like a little backwards check mark. So then we'll set up for our other one. F of x equals 4 would be our other equation. Our x's that time go from what to what? 1 to 8. What are our circles going to be, open or closed? Yep, these are both going to be closed. These both have the or equal to. So these are going to be closed. So then since our equation is just f of x equals 4, when x is 1, the equation is 4. 2 is 4, 3 is 4, 4 is 4. It's always going to be a 4 because there was no x for you to plug anything into. So we can go ahead and plot that one. There's no arrows on any of your graphs here because we had a start and a stop point for all of them. So we have a little check mark and then a little straight line piece.